This is problem 131 of Neetcode 150, merge intervals. So in this problem, like in the previous one that we just did, which was called insert intervals, we are going to be given an array of intervals, and each entry in this array is going to be an array itself containing two values, the starting index and the last index. This time, inside our interval that we're given, it is possible that we have overlaps. In fact, there are more chances that we have intervals that we don't, because this is going to be our task. It's going to be to basically output an array that has no overlaps. So for example, if I took the example 1, I'm given the intervals 1, 3, 1, 5, and 6, 7. Notice that 1, 3, and 1, 5 overlaps each other's. So what we're going to have to render is basically 1, 5, 6, 7. I think it makes sense, right? We just basically acknowledge that 1 and 3 is basically a subinterval of 1, 5. So we're just going to render 1, 5. And then in the example 2, we have 1, 2, and 2, and 3. But these are actually overlapping at the 2. So the only real interval that we have here is 1 to 3. Great. So we are going to solve this using greedy approach. They suggest us to have a time complexity of big O of n log n. We are actually going to do something quite better than this. And in terms of the space complexity, we are going to have a space complexity of big O of n. So let's go on a whiteboard and see how we are going to solve this. So let's say these are our intervals, okay? Just by looking at this, we know that we are going to have to output 1, 7, and 8, 9, right? I think that makes a lot of sense for all of us. But what is going to be the approach to solve this? So the approach is going to be, I will create basically I will basically create an array that will contain the value that each starting index will finish at. So for example, this starting index or this starting interval finishes at a few. This one finishes at 6, pardon me. This one finishes at 7. So what we're going to do is that we are going to keep track of for each starting index, if they are the same, I will just keep track of basically the maximum value at which it ends. And this maximum value should be the one at which the interval stops, right? So I will actually create an additional space here because I want to make sure that I can refer the specific ending index for each open index inside my array that I'm creating here. So my little helper, I want to make sure that I can access that by using directly its value. And since the value are basically going to be starting at 1, I don't want to include the index 0 in it. And I don't want to basically remove 1 to the starting index each time I want to refer to its closing value inside the array that I'm creating. So I will just create an additional space. So 4, 5, 6, and I go up to 8. And why am I going up to 8? Because I'm referring to all the places I can technically start at. So I can start at 1, I can start at 8, I can start at 9. So 9 is gonna be in there. And initially, I will set a value that cannot be reached to each of these values. So I know that it is impossible for us to have a starting index that ends at -1. So I will put this as the base case. You can potentially put infinity, negative infinity. You can put negative 10,000. You could probably not put like 7 into each of these cases because it is highly possible that 7 will also appear inside our interval. So that will create an error. So I will set a default value to all of these. My default value the one I decide to go with is -1. Feel free to change it if you want to. And what I will do is that I will basically go through every intervals, and I will take this starting index, and I will go, and I will go see, and I'll go change basically its values inside my helper array to be whatever is the greatest value between what it currently is at. So right now it's at -1, it's the default value, so of course it's going to be p'd. So it's going to be the greatest value between what it's currently at and the second value, so the ending index here. Okay, so right now it's going to be a battle between -1 and 2. 2 is going to win this battle, so it's going to have 2 here. Now we're done with this. I'm just going to pick another color here, so it makes it a little bit clearer. So now we're done with this. All right, now we're going to go see this one, and we will pick the first index, so position 0, and we will go see that same index inside the helper array that we created, and we will go see if the value that we have here, so the ending value, appears to be greater than what is there currently. Well, it is going to be, right, greater than the previous value, which was 2. So now we're going to have a 6 at this position, and we're done with this. So we're gonna go see the next interval, and we're gonna do the same thing. So we'll pick this value, and we will basically go see the array at this value inside our helper array, and this value, which is currently 6. Well, the value at the index 1 is going to be 6, and you want to take the second entry inside this interval, or the closing interval value, and see if this closing interval value appears to be greater than what currently is set at, which was 6. So the answer is yes. So we're going to put a 7 here. And now we're done with this. Now we're going to go see the last interval. We're going to go at the index 8, which is there. And we're going to go compare its current value, which is at the moment -1. And we're going to compare this to our second index, or our second entry inside the interval, which is 9. And we are going to set this to the greatest value between the current -1 and the 9. So it's going to be the 9 who's going to win the ball on this. All right, so this is good. Now just take a quick mental imagery of these intervals, because I will erase them. But I just want to basically write the answer that we should be at the end. So we should have basically a 1, a 7, a 8, and a 9. And you can already see from our helper array that we created basically this same expression. So the 1 is pointing to the 7, the 8 is pointing to the 9, and all the other ones are pointing to a -1, so they are not correct. So you can basically see that we're going to have to find a way to convert this into actual arrays. So we'll do this right now. And we actually no longer need our intervals at this point. So what we will do is, it's basically it. So we will create a starting index. So my starting index will initially be -1 or -infinity or -infinity. So let's say I put this to -1, and I will have I'm just gonna put S for starting index. So alright, so start is gonna be -1, and I'm gonna have an ending index, which is also gonna be initially start to -1, just so we can override it later and we don't have a conflict with the values inside our helper array. So what I will do is that if basically the value at a position appears to be -1, I just want to skip it. But from the moment that there's a value that is not whose value is not -1, I will put the start to be equal to the index. So right now it's going to be set at 1. And I will put the end to be the greatest value between what it used to be, which is -1, and this current value, which is 7. Okay, and now I'm going to move my pointer. So now, right, we are at index 0, we're at index 1, we're at index 2, we're at index 3, but we have -1, we're at index 4, we have a -1, so we skip it. We have a 5, -1, skip, 6, -1, skip. Now we have a 7, but take a look at this. Since we have a 7 and the ending index is 7, what we're going to do is that we are going to already append inside an output array the start and the end value as they are inside an array. So just like this. And once we do that, we are going to set back the starting index and the ending index back to -1. So now when we reach the next value, we're going to check again if the value is a -1. If it is not a -1, and the starting index is -1, meaning that it is not set, it's our default value, well, we are going to set the starting index to be equal to the index that we just found a value at. And we're going to set the end to be the value it is pointing at, as long as it is greater than our previous -1. All right. And now we're going to end our entire array. So what we're going to do is that we are going to append this 8 and this 9 in this. And notice that by doing this, so by following this exact formula, we are going to basically get the answer that we were looking for. So let's go ahead and code this. So first thing of all, I want to see what is the maximum value that my intervals can start at. And this maximum value will be basically the length of the helper array that I want. Okay, so this is why I'm going to find the maximum value. So let's create this. I will call it max val, and I will basically set that to be the greatest value between for the starting index of all the intervals. So for I in intervals, so I think you understand what this is doing, hopefully. Otherwise, take some Python courses. Then what I want to do is that I want to create a map I, and this is basically my helper array. So I'm just going to call this a map I for map of the indexes. And this is going to be set to couple -1s. And I want to have a -1 for all the indexes. All the indexes that I can start at. So it's going to be multiplied by max val plus 1, since we are adding an extra space. Great. And now I want to go for every single interval. So for each interval, I have a starting and an index. So I will say S for start and E for end. So for SE in intervals, and now I retrieve the two values in each intervals. What I want to do is that I want to say that the map I at the index of the starting position is equal to the maximum value between its current value, so map I at S, and the ending value we just found. Great. And now what we can do is that we can basically create our algorithm where we go through our helper array, because at this point we no longer need the intervals. We're just going to follow the helper array, and the helper array is going to help us build the output array. So I will create an empty output array initially, and I want to have my starting index, which is -1, and my ending index, which is also -1. Hopefully you remember the video. So then what I'm going to do is that I'm going to go for every single value inside my helper array, which is called map I. So I will say for I in the range of the length of map I. All right. And I want to check if its value is not -1. So if if the map I at the index I is not equal to -1, okay, this is where we have a couple of things to do. First of all, we have to check what is the start. If the start is at a default value -1, we know that we are going to have to create another sequence, another interval. So we will do this right now. So we're going to say basically if the start is equal to -1, we're going to set the start to be basically that current index. So we're going to start a new interval at this index. Great. So this is pretty good. Now what we want to do, whether or not we are starting a new sequence, we want to see what the value is, and we want to see up to which value this particular interval is going. So what we are going to say is that we're going to basically set the end to be equal to the maximum between the ending value that it is at, so its current value, and also the map I of that particular index. So like, for example, if we have 1, 6 and 4, 9. Okay, so now let's say that we go to 1. So start is going to be equal to 1. And then on that very first round, our end is going to be set to 6, right? So n is going to be 6. But then when we keep going, so we see this here, we're going to set our starting index is already set. So we are already inside an interval. But within this interval, we found a value whose ending interval value is greater than our current ending. So we are going to put this equal to this greatest value, which is 9. And so we're going to end up having an interval of 1 to 9, which is what we're looking for. Okay? So this is what we're doing here. Great. So now, there's another thing we want to check. Regardless of whatever the value is at this position inside our helper array, we want to check if I is equal to the ending array. If it is, as I've shown in the example, we're going to append to the output the start and the end as they are. And what we're going to do is that we're just going to reinitiate both. So the start will go back to -1 and the end will go back to -1. And at the end, if our start is not equal to -1, this is just to this is a check just to be safe that we're doing here. But obviously, like in my example, my starting index will not be set to -1, because when I end the array, I end at the position of the value 8, right? But my ending index is going to be 9. So there will be no index where basically the index is equal to the end. And notice that we are only setting our starting and our end indexes back to -1 when the index is equal to 9. So if it is not set to 9, well, we are going to have to append our start and our end like this. So our 8 and our 9 at the end of this for loop. Because right now in our for loop, we are only appending to n if the I is equal to n. But it is possible that the n is actually a value that will never be reached by our index. So if at the end of this loop, our starting is not equal to -1 and hasn't been resetted, it means that we still have a start and an end value. So an interval that have yet to be included to the output. So what we will do then is that we will say output that append start and end. And with that being said, we can return the output. So if I didn't do any error in the conception of this code, it should work perfectly fine. And it works. Awesome. So that's pretty good. For the space complexity, well, we are basically going to have an array of len n, right? And for the time complexity, we're going to have n plus m, where n is the len of the array and m is the maximum start value, right? Because we're going through every single value that could potentially be reached, even those that are never going to be reached. So for example, in my previous example, we're going through 2, 3, 4, 5, 6, 7, even though like they don't really serve any purposes except building the array. So this is why we have a time complexity of big O of n plus m. And with that being said, I hope you enjoyed the video, and I hope to see you in the next one.